Hello and welcome back to the second part of our on-chain Solana game tutorial, where we're gonna build a game similar to Twitch Plays Pokemon, where multiple players can control their characters on the screen and fight against each other. And in the first part, we already had a character that we could move left and right. And today we're gonna add giving rewards to the players, so we're gonna make it a play-to-earn game, basically. So this is how it looks like in Twitch Plays Pokemon. There's a chat on the side which controls a character. And what we're gonna do today is build this in Anchor in Playground. So in the second part, I'm gonna show you how to spawn a chest. And then as soon as the player collects the chest, he will get the soul that is in the chest. And if you're lucky and the tutorial is already live on the Solana Playground, you will be able to select it here. And I will quickly show you how it will look like when we run it. What it will do is it creates a new account, then it spawns a chest, then it moves the character 3 times, and then it collects the chest again. And we will be able to see here the logs. So the first one is initializing the accounts. Then we can see here the sol balance that we have. It's currently 7.4 sol. Then we can see here level reset and chest spawned. Then we have this little character here and the diamond in the end. Then we can see that our sol balance went down by 0.1 sol, so it's 4.6 now. Then we move the character to the right. Then we move the character to the right again. And then when we do this 3 times, then we are at the diamond, collect the diamond, and we can see that our sol balance is now 4.7 again. So we collected the chest. But also another player in the meantime could have also collected this chest. And yeah, now we're gonna build this thing. I'm gonna start on the tiny adventure tutorial from last time and then program it so that basically the second tutorial comes out. And for that I even drew a flowchart. So the first thing we're gonna do is we're gonna initialize 2 accounts. One is the chest vault, which has the seed chest vault as a string. And it has lamports where we put in the reward for the chest. And then we create a player account, which has the seed level 1 because it's the first level. And it has a U8, which represents the player position. Then the player can reset the level and spawn a chest, which will move the character to the position of the level again, basically setting the UInt to 0. Then he can move right. Then we check if the player has finished the level. If he did, then we transfer the soul of the chest to the player. Then the game is over, and then another player or the same player can reset the level again and spawn a chest. And if he did not finish the level, we can just move the character forward, and then we can call move right again, and so on until we are at the chest and can collect it. Okay, so now we can go to the Solana Playground. The link for that is beta.solpg.io. And what I'm going to do is I create a new project, a new anchor project. I call it Tiny Adventure 2 and create it. And then I just gonna, for now, copy the code from the Tiny Adventure 1 so that we have a good starting point. So I copy the Rust program. And the client we're gonna write later. So let's look in the flowchart again what we need. We need to initialize an account, which will be one instruction. Then we need reset and spawn chest, and we need move right. So let's look at the instructions we have already. So we have initialize. We're gonna call this initialize level 1. This will be level 1. We have a new game data account. This will stay the same. The signer will still be the signer. It will also stay the same. And we need the system program to create a new account. So we don't need move left anymore because we will only be able to move right. And for the and we need one more account, which is the spawn chest. So we're gonna call it reset level and spawn chest. So for that we need a new account, which is the chest vault. The chest vault doesn't have anything, we just need the lamports that are in the account. So we're gonna call this reset level and spawn chest. We need here the chest vault account. And this one needs to be a PDA again, otherwise, and we need to check the seeds and the bump. Otherwise, yeah, the user could just put in any account that he wants, and then we would basically pay for, like, the wrong account would pay for it. No, it would be transferred into the wrong account. So we need to add these seeds here. So the comma needs to be, the bracket needs to be here, and so we're gonna have the seed and the bump, and the seed will be chest vault. Okay, so now we have our chest vault account and we have our game data account. If we initialize, we need to initialize also the chest vault. So we're gonna put the chest vault here, we're gonna put the same seed here, and the payer will be also the signer, and the size will be 8, which is just the size of one account. Maybe I make this even bigger so that you can see it. Is that big enough? No one's answering. No, okay, it's not live, I guess. Okay, so we're gonna call this account chest vault. And the signer will be the signer. The payer will also be the signer. Then we're gonna move right. And for move right, we also need the chest vault. Otherwise, we will not be able to transfer the sol from the chest to the account. And we need the game data account, and we also need a signer. And the signer will be the one that we will pay the sol out to. Okay, so move right looks good, chest vault looks good. And for the reset level and spawn chest, we also need a signer so that he can reset the level. And we need the game data account because we want to reset the game data account back to the player position back to 0. So I wonder if here we need the system program. I think we need the system program as well because we want to do a transfer. And for the transfer is a system program cross program invocation. So we need the system program. And I think in move right we will also need it because we want to, when he reaches the chest, also transfer the sol to him. Okay, so now here on top, first of all, we're gonna remove the move left because we will not need it. And then we will add the spawn chest and reset level. So I'm gonna call it reset level and spawn chest. Okay, so we're gonna get the game data account and we're gonna just put the value of the player position to 0. So this is already resetting the level. And then we want to transfer now sol from the signer to the chest vault. So how we're gonna do that is we do a cross-program invocation of the system program with transfer. So for that, we first gonna look up system program transfer because that's what we want to do. So we look at the system instructions, then we click on transfer and we can see we need a from pub key, a to pub key, and the lamp ports. Next thing we're gonna do is we Google for Anchor example system program transfer. It's like the easiest way to figure out the syntax. And here we can see to send native sol using Anchor, you can use the following code inside your instruction. So we just gonna copy this and then look at it if it looks correct. So we're gonna get an instruction, transfer instructions, and we put in from the context the accounts from to. So we want from will be the signer, and to will be the chest vault. And then we do a cross-program invocation. So we invoke the program, system program, with this instruction. So maybe we call it transfer instruction, so it's a bit clearer what it does. And then here's the amount. The amount we're gonna put here on top. Cost, we call it reward, chest reward, I would say. Chest reward. And this will be a U64, and we just put some arbitrary number for now. We're gonna make it nicer later. So we put amount here. And now maybe let's build to see what we did wrong so far. So we have from signer. So from the signer to the chest vault. Let's build it and see how many errors we have already. Oh, it's only 3, so that's not too bad. So we don't have an initialize context here, but instead we have the spawn chest context. So let's build again, and spawn chest doesn't exist because it is called reset level and spawn chest context. So let's put this. Then we build again, and now we only have 3. So initialize doesn't exist because we called it initialize level 1. So let's put initialize level 1, build it. And this time it succeeded. Wow, that was quick. Then here we want in the move right function, if the player position is at position 2, we know that we want to transfer soul to the player, because then he will be in this move reach the chest, and we want to give the rewards to him. So, but what I figured out is, and we could try this, but this will not work in this case, because you can only call the system program in transfer with accounts that are owned by the system program. And our chest vault is not owned by the system program, but it is owned by our program here, which you can see here. The chest vault is has seeds. So that means that it doesn't, like, it's not a normal wallet which has a private and a public key, but it's basically taking the program ID and adds the seeds on top, and it's like a program address now. So, but there's a workaround for that, which I will quickly Google for you. So I Googled that, and this is how I solve all my problems, basically. And I want to recommend you also to visit the Solana Stack Exchange from time to time, because it's really good. Yeah, but basically what we find here is that we can directly borrow lamparts from an account and then transfer it to another account. So basically what this does, it takes the, it takes the lamparts, like it takes the account info of our chest vault, and our signer. And basically what it does, it subtracts the amount from one account and adds it to another. What's very important here in this case is that the amount of all lamparts always stays the same. So if we remove 100 lamparts from one account, we also need to add 100 to the other account. So we're just gonna put chest reward here, and then we're gonna put chest reward here, and then this should theoretically already transfer soul back from the chest vault to the player. I think it needs to be chest underscore vault. So let's build it again, and successful. Nice. So I want to talk quickly about security, because if this here, for example, the chest vault account would just be a normal account info, then we could basically pass in any account here. And yeah, since we would not check if it's a program owned account with the correct seeds. And then basically what could happen is someone spawns a chest, but for the chest vault, he just puts his own account. So he would spawn a chest, but the soul would go to his account. And yeah, that would not be good. I mean, in this case, it wouldn't really break something, but still it's way better if we just put an account here and also like initialize it with a type of chest vault. So, but I think this is already most of what we need to do for our example here. Like when we are at position 2, we're gonna send the chest to the player. Oh, but also need to we also need to increase the size of the position, because otherwise we could call it over and over again and get more and more sol out of the chest account. And then at some point it would not have enough sol anymore, and then it wouldn't be rent exempt, and then maybe at some point it would just be killed by Solana. So, and if we are at position 3, we say reach the end, super, and otherwise we increase the size by 1. So this is all looking good. So now we're gonna build the client for that. So first we need to find a program address. So let's quickly Google how that is done. Find program address, TypeScript. So find program address. So here we can see find program address takes seeds and the program ID. So we're just gonna write this. So we want a const public key. Let's call it chest vault pub key equals to. So I just copy it from another program, like from the other example. What we need to do is we need to await anchor web3 public key find program address, and then from buffer, from the seed, we put now here the same seed that we have in the backend, which is chest vault, and we just put the program ID as well. So this will be our chest vault. And then the second thing we need is our level 1 pub key. Level 1 pub key will be level 1. Let's quickly check if the seeds are correct. Chest vault, level 1. Okay, so now we have the data already, and now we can call the instructions. I will also just copy one from another program. So what we need to do is we take the program methods, and instead of initialize, we now want to call, how is it called? Oh, it's still initialize. And for the accounts, we need to put in, let's check the context. Initialize needs the new game data account, the chest vault, the signer, and the system program. So the system program we have already, the signer we have already, the new game account we have already, will be the level 1 pub key, and we also need now the chest vault. Chest vault will be this one. So let's quickly reload, because I think sometimes it just doesn't get it. Chest vault is wrong. Maybe I mistyped it. Chest valut I wrote. Okay. Chest vault. Okay, so this should work now. Now we're gonna build and deploy the program by just writing here build and then deploy. Yeah, for some reason, now that I do Solana airdrop 2, I get internal errors, so I just gonna try later again. I guess I got rate limited. So that took a while, but now I have 6.7 sol. So now I should be able to deploy. So deploy is done. So now let's run this and wait for the transaction. Let's call it result. PG connection dot confirm transaction, and then we put the transaction hash. So this will basically wait for the transaction to go through. Run. Hash was not written correctly. So let's run. So this should now initialize our accounts. And then what we will do is we we reset a level. So we just copy this. And instead of initialize, we gonna reset and spawn chest. And we don't need the game data account, but instead we will need, what do we need to reset the level? Reset level spawn chest context. So we're gonna need the chest vault, the game data account, the signer, and the system program. So the chest vault, the game data account, so we still need that actually. So game data account we put in as well, and this should actually be correct. Why is it red? Because it's not new game data account, but it's just game data account. Okay, so here we're gonna put let, and then remove this, and now we should be able to initialize and reset our account. So to be able to look at these transactions on the in the Explorer, we need to print out the hash. So let's just say hash, and for the second result as well. And then we will be able to look at the results. And then the next thing we're going to do is we just do a simple for loop and move to the right 3 times, and then we'll be able to collect the chest. So for that we just write a for loop. So we let e be equals 0, then as long as e is smaller 3, we're gonna increase I, and then for 3 times we're gonna do the same thing as here. So we copy this, but instead of reset level, we do move right. And the accounts are the same, I think, for move right. Yeah, it's game data account, chest vault, signer, and system program. So we're just gonna move right and print this. And maybe what would also be nice if we print our soul balance, we see that we are actually giving out the reward. The soul balance we can also get from the connection, the PG's Playground connection. So we're just gonna do let balance equals PG connection dot balance, get balance. And we need to await this, I think. And then we just gonna print the balance. Sol balance, and put this in here. So balance is red. So we need to put our wallet address. So pg.wallet.pubkey. Okay, so we want to print our balance after we initialize the accounts. Then we do it again after we set the level. And then we're gonna do it after each of these move right actions. And now let's run this. And now we should be able to spawn a chest, collect the chest, move right. So our soul balance is 35,000 something, but here you can see it went down by 0.1, actually 0.01, and then we moved right again, and in the end our soul balance goes up by 0.01 again. So now we're gonna look at these on the chain. So we are on DevNet. We're gonna put the transaction hash in, and here we can see that we returned successfully from reset level and spawn chest. Maybe we should add some more logging in the program itself. Let's do that now, so we can better see what happens. Actually, in the live game, you would probably not want to put too much logging into your program because it costs compute units, which you don't really need to spend on logging stuff. Some more logs here. For example, we want, when the player collects a chest, we want to tell him that he is awesome. You are awesome. You made it. Have some soul. So the player will get this amount of soul here, which apparently is 0.01 soul. So we increase it by 1, then it will be 0.1 soul. And then we want to tell him that after he resetted the level, that he level was resetted and chest spawned at position 3. And what else do we want to log? Here we have print player. This is like from the last example. So maybe we could, well, I think that makes sense. It's like just journey begins and in the end you reach the end. Super. Okay, so I'm gonna build and deploy this again, and then we're gonna run the program, and then we look at all the transactions. Yeah, but also add some more logging in the client so it looks nicer. First we remove this balance here, and then we write after he spawned a chest something, and after each step. While fixing the warnings that I have here in my program, for example, that the transfer instruction needs to be snake case, I noticed a nicer way of doing cross program invocations in Anchor. So as you can see here, we created the transfer instructions with these two accounts and the amount. And then we did Solana program invoke with this instruction, and we passed in the two accounts again. So that's a bit annoying. So I found a nicer way, which is creating a CPI context. Then we put in the program, and then we put in the instruction with the two accounts. And then we just call system program transfer with this CPI context. And how I found out about this, I looked at this CPI context, and it has a constructor here, new, with the program and a bunch of accounts. And then the system program transfer takes also a CPI context and a transfer instruction. So basically, if you combine these, then we only need to pass in the accounts once, and it looks a bit nicer. I'm not 100% sure what the disadvantages or advantages of these two are, but I find this nicer, and they both do exactly the same thing. But you don't need to pass in the accounts twice if you use the CPI context. So that's nicer. So we're gonna build this again and then see if there are warnings left. So no more warnings. So I'm gonna deploy the thing again, and then we run the client, and then we look at the transactions, and then we're already done. So I'm gonna run it. Just type run here on the bottom, and then the first thing we're gonna do is it initializes our game, our accounts. Then it prints the hash. Then we reset the level and it spawned the chest. And then here in this loop, we move right 3 times. So now we are at 2 already, and then we are at 3, and then we collected the reward. And we also got the reward because from 34, it went here to 35. So now comes the fun part. Now we're going to look at all these transactions. So I just copy them and put them here in the Explorer. And then we can see the first instruction costed us just the transaction fee, so 5,000 lamperts and nothing else, because accounts were all already initialized. Then the second instruction, the spawn chest, costs us 0.1 sol plus 5,000 lamperts for the transaction fee. And here we can see the chest account got, the chest vault account got plus 0.1 sol. And the others were not changed. And here we can see the level was resetted and the chest was spawned at position 3. Then the third transaction is move right. It cost us 5,000 lamperts, and the little character moved a little bit to the right. Then the next one is the same thing again. It costs 5,000 lamperts, and we move to the right again. And now the last one is where we collect the chest is the chest vault was decreased by 0.1 sol, and our account was increased by 0.0999995 sol because we still had to pay the 5,000 lamperts. So yeah, now we have a pay to play game. No, pay to play, and yeah, that is it. I quickly gonna show you maybe afterwards how we do some tests, because tests are boring, but tests are also important. So we're gonna write a little test here in the test client. So we're gonna test when we spawn a chest that the lamperts are decreased by 0.1 sol in our account. So for that, we don't need this data here. We create a new account. We need the accounts, the same as here, the PDAs. So I'm just gonna copy them over. And then we want to call reset level and spawn chest. So here, this is here starts the test, and here is the name of the test. So I now just gonna copy the same thing in from the client. So we now have the reset and level and spawn chest. And I just gonna check the soul balance before and after, and then I'm gonna assert that the soul balance is what I would expect. So we're gonna get the soul balance once before. So I call it balance before, and afterwards I gonna call it balance after. And then we just gonna assert that they are the same, but not completely the same, but minus 0.1 sol plus 5000 lamperts. So for that we're gonna copy the chest reward from here, so that we have the reward in lamperts. And then I'm gonna create another one, which will be the transaction cost. Transaction cost, and this one is 5000. And then we just gonna here in the end assert that the balance before is equal the balance after minus chest reward minus the transaction fee. And now if we run the test, that one should be green. And now we have at least a little bit covered that our program is not doing something completely wrong. So the test failed, which is good. Tests should always fail on the first try so that you can actually fix it. So I'm gonna quickly print the balance after and before, and then we can see what went wrong there. So I'm gonna print this one before and after, and now we're gonna run the test again. So the balance before is 34.3, and the balance after is 33.3. So it's a little bit different. Let me quickly figure out why. Yeah, looks like I wrote balance after here twice. So this should of course be balance before. And now we should have the correct values. So 333 before. And after we spawn the chest, it should be 0.1 sol less and the transaction fee less. And then the test should be green. And yeah, while we wait for the test result, please subscribe to the channel, like, and follow me on Twitter, and do all the cool things. And send me, please, games that you're building, because I'm very excited about that. And the next thing we're gonna do is, I already started programming it. It will be that the character can move up, down, left, right, and that we can also identify the different characters. And then we will build a chat program for the site. And then the idea is that we make a tutorial about composability, which means that one program can call the other one. And we're gonna, in the chat program, whenever you write up, down, left, right, we will do a cross-program invocation to our game, which then will also move the character up, down, left, right. So that should be very interesting. So I hope to see you next time, while I quickly figure out why the test failed again. Maybe it was just a timeout. Yeah, looks like it was just a timeout, and this time it went through, so it's passing, so we can be 100% sure that our code is perfect. Of course not, but yeah, in the example that I committed to the playground, there's a few more tests that you can look at then, and you can, as usual, find them here if you go to tutorials and back to tutorials, and you can see them here. And I hope to see you in the next video and the next tutorial. We finally should be able to play the game, and then we will also build the client finally. And you can write me in the comments if you would rather have a JavaScript client or a Unity C# client, and then we will do it in a different order maybe. See you next time. As a little bonus, in the next few minutes, I looked a little bit at the different CPI context calls, but I thought not everyone might be interested, so I put it at the very end of the video. So I kind of wanted to know what the difference between these two methods are, to do a cross-program invocation. And I looked a bit in the code, so I went from the CPI context to the system program, Rust. And then I found here that this is basically exactly doing what we had there before. So it does the transfer instruction, puts in the two accounts and the lamperts, and then it invokes it signed. So basically our solution is now the same as before, but it is just a bit smaller, and it's just convenience functions. And then I wanted to see a bit more how it goes even deeper. So what it does is it calls transfer in the system RS, which then calls system instruction transfer with the lamperts. And this basically calls in the system instruction processor transfer. And the funny thing is that this then basically does almost the same as we do here in the other one. So it like takes from the account info the borrowed lamperts and adds and subtracts from the other account. It just does it with a few more checks. So here, if you can see this transaction verified, it does check sub lamperts from the from account, and then it does checked add lamperts from the to account. Yeah, so basically now we know what's happening there. So now we can run our game.